Hi, good morning. Here we are. I'm doing this on YouTube this morning. I couldn't seem to get on Facebook Live. I don't know what's going on there, but maybe they are overloaded, over capacity. Today, we need to continue to talk about COVID-19. Why does that look like it's backwards? Well, we will go without words, won't we? How's that? Let's see if I can fix that. Interesting. Okay, so there's a new finding with children that are coming in with under age 5 and with symptoms that are similar to what is called Kawasaki disease, like the motorcycle Kawasaki. And so what does that mean for us? Well, if you look at these symptoms, they're involved with cardiovascular, again, skin discolorations that we're also seeing in the mature virus hypoxemic patients, and also what they call strawberry tongue, which is very unusual, this unusually hyper red tongue. It looks like a strawberry. I was reading one peer-reviewed publication on this, that this disease, Kawasaki disease, is primarily in Japan. And it's like 9 out of 10 cases happen in Japan. And most of those cases, like 99% of those cases or 95% of those cases, happen with children who have a non-traditional diet, as in a high carb, high fat, Americanized diet. Now, that's only the beginning of the scientific kind of exploration of what's going on there. So what's in the Japanese diet? Rice, lots of fish. I'm not really sure what's in that Japanese diet. I know I eat Japanese. I know they fry their food, tempura, the things I know, the Americanized version of the Japanese diet. I'm not a specialist. A lot of prepared salads and things, the wasabi. So how is that? What is the difference there, like in the evolutionary sense, between that diet that protects from these alleged new symptoms? I'm not sure about this children's, they may be predisposed to this Kawasaki type-like condition. There's also conjunctivitis of the, red eyes and that associated with that. So that, to be continued as far as what's going on there. Wow. We can oxygenate. We know that, this COVID incubates in our lungs. The scientists know that. There are stages of aerobic metabolism. I did make a mitochondria here. And when oxygen comes in, let's call it O2, put it up here, that it is received by the mitochondria, split. Everything's split in here. There's two of everything. And it's split to create 36 units of ATP. That's what the mitochondria do. And that's how we've evolved. We talked about that at length recently. And that evolution is an aerobic, air-rated, oxygen evolution. We're out and foraging around, and we never know what was coming next, but we were responding, and there's a lot of beauty, and the world was teeming with life, wonderful life that threatened us. It wasn't all threats, just like today. It's not all threats. Birds aren't threatening me. They're enhancing my experience of life. Animals, turtles aren't threatening me. Frogs aren't threatening me. A lot of things that just aren't threatening me, aren't interested in me. And so that's the majority of life. The majority of the life on this planet is non-threatening to me. So in the Darwinistic sense, I can say that 90% of my time, I'm not going to be threatened. But when the threat does come, I have a mechanism within me that is hypoxic where I can escape it. It's hypoxic. It connects to my amygdala, which is a small area of the brain, but strong. We've still got it. We're still locked into it. That hypoxia is related to anxiety, allostatic load. That means you're anxious for year after year, day after day, worry. We have a very vivid, I call it the rudder of the ship. That rudder, I don't know where we're going. Going this way, that way, that way. We could go this way. If we went this way, what would you do? Is that how you want to sail your life? But if you're micromanaging the rudder all the time, this is the frontal lobe, about 3%, maybe 5. If you're J.S. Bach, maybe 6.5 or something. But the rudder. This is the rudder, and that it. So you say, you know what? I'm going to play the piano. I'm going to do my morning lecture. I have a job interview that I'm going to prepare for. It was Mother's Day yesterday. I need to get my Mother's Day gift to my mother. And other things. Little things. A couple of big things. And just small little diversions. But I'm not sitting on that rudder all day. Because if you sit on the rudder all day, this doesn't have a chance to work. It's as confused as you are. We don't need to do that. So it's a conceptually a way to understand how we've evolved to to make choices, and those choices have consequences, have outcomes. And so to the degree that we can shed the junk, whatever family junk, I've got plenty of that these days, whatever societal barriers or hurdles, challenges, as it were. I'm getting ready to go into the next stage of my career. There's a lot of unknowns, but hey, I need to just be present and available for that. And that's kind of exciting. And I have a lot of people helping me. Thank God for the people who love me and know me and help me and support me. That's who, that's my foundation. So, but what I'm saying is that I'm getting advice, people who have been there before me, who have sailed these seas. Where should I put my rudder today? And they'll say, well, this is your priority. I'm like, okay, well, thank you. I'll take that course. And I don't even have to think about it anymore. I stay oxygenated. I show up on the ship and I navigate. I navigate whatever details come along in my day, on my journey. So that's evolution. That's evolution. We've changed that. Industrialization has changed that. Let's go ahead and get rid of this for now, since I'm getting a reverse. Looks like I'm, everything's backwards here. I don't know how to fix it. So COVID-19 concerns me because when it was an aerobic world and air, oxygen, we had no choice but to all right, I have no idea what's crawling out of this world today, but I know 90% of it should be good. And, if I have to run and I know I'll have a chance of survival because I have reactions, right? That will help me escape and be unpredictable to the predator. That's what the amygdala does. Anxiety and stress. It's like you see something and you don't even know what you're going to do. You don't know how you're going to respond unless you're, big seasoned warrior or whatever, hunter and such. That's wisdom, experience. That's age and experience-based wealth and understanding. That's wisdom, aging, brain, wealth, which is what I study as a scientist. So, but if you're young and something happens and, you don't know what you're going to do. So you become erratic. And we have instincts, and that whatever you've come across it may be threatening, also can anticipate where you might be going. But if you don't know where you're going, it can't anticipate that. So what does that mean? That means this thing is as confused as you are. I don't know what it's going to do. And you say, well, I'm going this way. And it's like, daggone, I didn't see that coming. And so you escape, so it protects your ability to escape this confusion, this low oxygen. Low oxygen is responsible for epilepsy, for the progression of dementia. You look at the 2019 Nobel Prize to Greg Semenza et al. It's responsible for all disease that's non-toxin or metallurgic based, as in Northeast Brazil, microcephaly. So it's wonderful science. It's new science. It's science. It's foundational science based on discoveries. Many, 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 many. Oh my gosh, I'm standing on the shoulders of so many lifelong committed scientists who've done so much work, and I've come in as an artist, committed, and just getting picking the fruit from all of these silos of research, and saying, wow, this all fits together like a puzzle as to who we are and where we're going and how we can evolve within a human lifespan as a continuation of how we have evolved with oxygen. I was a singer for many years, so that was my main thing. Oxygen, phonate, message to the herd, and grow, rest, take good care of myself so I could message some more without a microphone, thousands of people. So that is an evolutionary type event, and we can apply it to modern awareness, modern health, the ability to evolve within a human lifespan that has depth and substance and content and value. And we're building on the backbones and the work of many, 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 many geniuses over the centuries that began with the Enlightenment, not that many hundreds of years ago. So we are continuing to evolve. This virus has moved in on us because what are we doing now? Surrounded by plastic. There's no stimulus. There's no, we're pretty much eliminating the life on the planet. It's a little grim, but this COVID-19, I believe, emerged from this industrialized world that we've created. And that's not unrealistic to hypothesize upon. The kind of iron we've unearthed, the oxygenation we have displaced or eliminated by deforestation. So the virus is a manifestation of, I believe, what's this industrialized planet. And I'd like to look at the 1918 influenza virus, which is maybe a precursor that in the similarities and such as part of this journey I'd like to be on as far as we look at this virus. So my concern is that we are humans, and we are in an oxygenated status after millions of years. And this virus, this is our oxygenated with mitochondria that are in our cells producing ATP. So if I write that backwards. I could do that. Let's see. Mitochondria. I love it. Now, this is an exercise. Oh my God, my brain's going to do that for me because I have a purpose here to talk to you about this. And when you have a purpose and you're a humanitarian, helping others, helping the hive survive, our instincts have evolved that way too. That's who we are. That's the best of who we are, I believe. So let's look at what we've got here. So ATP is made from the mitochondria, 36 units. Oh my gosh. No. Let's go there. I'm not going to put numbers up yet. And then the virus is moving in with anoxia. anoxia. I mean, this thing is, people are surviving with the virus in there, and this thing is mutating rapidly. And it makes me wonder that this is the CV1, oh gosh, 9. Is that right? Okay. This is the COVID-19, and this is mutating. It is mutating a lot. It's mutating until it gets the lock that it, I believe, may need to be one with the new industrialized biological human. Because guess what? It's been years this mitochondria has been getting less and less oxygen. We don't have to practice it. We're surrounded by plastic, food, glucose. And you know, for every glucose molecule, let's see, LU. Is that right? Yeah. For every glucose molecule, we're going to get 2 ATPs, you know? Right? I don't know if that's right. But okay, so we only get 2 of them. But for every oxygen unit, we get 36. So we are, our lower oxygen levels are less engaged. So, you know, where this is all going is a considerable, you know, foresight. But first we look at hindsight, which is how we evolved. And then we look at this virus that's moving in on our deoxygenated planet. How it's mutating. Excuse me. Now, if you look at, I'll just go for a few more minutes here, since I'm locationally challenged, up is down, backwards, forwards. Gallionella, if you look at it, it's all sorts of stringy things. It's got some shapes, and it's got all sorts of gangly, stringy things, right? Outside of our bodies. When you find it in near iron ore mines, iron and manganese co-localize with oxygen to create this bacteria that's really stringy and gangly and weird looking. And if you look closely, it pretty well looks like this, you know, a lot of that looks like this. And when you surround this mitochondria by water, you the gallionella, you get mitochondria. I'm going to put, let's see, GALLIONELLA. Can't believe I spelled that backwards. There it is. Oh, I got my L's backwards. L's. Okay, it's gallionella. So it's a metals-based living bacteria. And this is a whatever-based living or non-living virus. CDC doesn't know if it's living yet. They say it might be not living. Just like this might be not living. The gallionella might be not living. Oh, let's see. So this is in this shape. So this came in this shape. And maybe one of these gallionella got enough so it's got some of these things sticking out of it, right? Look familiar? Familiar? And that gallionella managed to get into, so let's say a gallionella managed getting enough water, but it still had these stringy things sticking out of it. Now this is very hypothetical, but worth thinking about, because guess what? This is mutating like you know what. And at the end of the game, what's this thing going to look like inside of our bodies, inside of those who survived? And where is it going to take us in our evolutionary trajectory? Humans have gotten 4 inches taller in the last 2 centuries, less on average. Taller, getting taller, you know? It's just worth thinking about. So, so let's say this is gallionella, GAL, and it found a group of cells, found a group of cells bubbling around in some stream, and that's they clustered together and had created some sort of a worm, right? That's what we study. We study these little worms that we think are that tell us a lot about who how life functions. So this Gallionella kind of finds a way to get into these worms, and once it's in the worm, this is a worm, humpback worm. There you go. This is fluid. This is H2O, right in here, or form of fluid. And so now this Gallionella has made its way in here, but now it's surrounded by water and fluid. And you know what happens when the Gallionella is surrounded by fluid? It becomes kidney shaped, like our mitochondria is. It all makes sense. Where there's causation, all you find is evidence. So, okay. So, but it still needs oxygen. Remember, Gallionella is iron, manganese, and oxygen, right? And oxygen in the presence of fluid, all right, in the presence of water, right? That's what makes Gallionella. So Gallionella has created a little shapy thing and emerged into this worm, which is a collection of cells that all need oxygen. They all need oxygen because we're in aerobic evolution, very clearly established. And once it's inside, it continues to mutate until it has the kidney bean shape. And there's our mitochondria. That's my hypothesis. It's a good one because it all adds up. Makes sense. And that's our source. That becomes the source of nuclear level fuel for us, for this little worm. And so that worm, it eats a little bit, but let's say it absorbs oxygen through its body. I don't know. I think worms can do that. So can frogs, right? Reptilians. They can absorb the oxygen through their body. So that oxygen is still getting to this guy, and it's fueling the system to grow and grow and grow and multiply and grow. This is origins of life. And I've been studying this for years with Harold Morowitz, oxygenation, transition metals, embryogenesis. I'm a musician. I love music and such. That's kind of my, calling card. But, my real scientific interests are in these facts and information. It just happens to coincide with what's going on right now. Okay, so this is oxygen. This is pre-industrialization, P-R-E, industry, I'm writing this backwards, Okay, there you go. Is that right? Close enough. Pre-industry, yay! I'm writing backwards. You can laugh. Hey, what else is there going to do, huh? Let's not take this too seriously. Let's just do something about it. We're learning what to do, what it is, maybe, and what we can do about it. So here's this virus coming in and sucking all the oxygen. It's not even sucking the oxygen, it's displacing it. It's like, we don't need oxygen anymore. But this virus does not, it seems to go towards the iron to get around, but it doesn't seem to need the oxygen. It kind of replaces it, strangely enough. So if we survive it, and what it's doing to us and how it's now maybe manifesting in children and such, it's mutating rapidly. And it's extremely contagious, more and more contagious, according to reports. So, the question is, where is this thing going? Where was this thing going? Where was this mitochondria going many years ago? Where the heck was it going? Well, it took advantage of what was going on at the time, which is, oxygen everywhere, a bunch of cells trying to find their way or crawl away, slime around. And here we are. Millions of years of that. So now we flipped this world, haven't we, with industrialization? That's the facts. It's the facts for the richest of the rich. It's the facts for the poorest of the poor. And all the extinct animals and deforested trees. We've got to take advantage of what we're learning from this and how we've grown from this quarantine. So where is this virus going? Some of us survive. 90-some% of us survive, and we still have it. We have antibodies to it. Time will tell, but this thing sticks around. It reemerges. Where do you think it's going to end up? I'm really concerned as to where it's going to end up. Just like, when the mitochondria, as we're saying, it came out of the Gallionella, and it got into the little worm, whatever, and that mutated to become our mitochondria, which are, pretty sophisticated things. And that mitochondria, they call it mitochondrial Eve. We all have the same mitochondria. Once it found its lock, it just stayed with us for millions and millions and millions of years to right here, right now. And that's how it works. We oxygenate this with an oxygen gradient, and we let that mitochondria just run the show, because that's all. Can't run that car without fuel, and you can't run that the mitochondria cannot run the cell without mitochondria and its fuel system. You can't run a car without a gas tank. You can have everything but the gas tank, and that car ain't going nowhere. That's what we are. We can have all the things in the world, but without that mitochondria, we're not doing much and nothing. You can roll it down hill maybe, or listen to music. That's free energy. Okay, so as this has transformed into its final shape, this COVID-19 is making mutations. Mutation 1 gets into the bloodstream. It's now in the bloodstream. Scientists are finally recognizing there are 2 stages of that. We've been talking about this for weeks. There's an incubation stage in the lungs, which is like our gestational first trimester stage, can be related to that, which is very different, very, 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 very different from the rest of our development. You know why it's different? Because the mitochondria move in at 2nd and 3rd trimester, and that's all that matters after a while. So this has that lung stage, right? And then and now it's had a mutation 1 where it's in the bloodstream. Oh gosh. Oh boy, another mutation 2. It's highly contagious. Everybody gets it. More and more contagious, going to children. What does it look like now, though? Has this changed? What's changing in it? They're saying this terminal is changing. The question is, do we want to stop this? Can a vaccine stop it? Maybe. Do we want to stop it? Do we? Or have we destroyed the planet so much we need this thing now? These are big questions. Big questions. Mutation. And so as this mitochondria mutated, this Gallionella mutated to become our mitochondria, this may mutate to become, God, who knows what? Who knows what? Who knows what? You know what? I would imagine it would be something like this. I would imagine it would mutate to have a lot of surface area. A lot of surface area. Why? Because it's not feeding on oxygen anymore. It needs glucose. Wouldn't surprise me if it looked like that. Because, all the glucose, it needs all the glucose because the glucose is very limited in what it can produce. In fact, it might create a symbiotic with the mitochondria that are no longer getting oxygen because that's all we feed it is glucose. I don't know. It's to be continued. To be continued. Be well, everyone. Take care.